Well, it is my pleasure to be with you again in a subject about aqueous solution. What is the properties and types of aqueous solution? So we will talk about the general properties, precipitation reaction, acid-base reaction, oxidation reduction, concentration of solution, and dilution. So let us start with this in very simple way about substance like solutes. Solutes is like this. If you look to sugar or salt, this is a solute. If you take the water, for example, then it is a solvent. From this point of view, we will give examples and we will discuss properties. So what about solution? It is homogeneous of mixture of two or more substances. So if we dissolve like salt in water or sugar, then it will give a clear solution like this part. And then a solute is a substance present usually in a small amount, while solvent is usually present in large amount like water. Let us take example about solution like soft drink or solvent is water, while solute should be like sugar or salt or etc. Then take example about also like potassium permanganate, for example, when it dissolves, it gives such clear solution. What about saturated solution? If we takes this amount of salt or sugar, and then if we add a solvent in the beginning, then you see here first is super saturated solution. Why? Because you still have this, even if you dissolve here, then it is still so much concentrated. But if you dilute it more and more like that, then it will be a saturated solution because all the amount will be dissolved in the water. This means that you get a saturated solution. So you see here, it is still not saturated. It started to be all dissolved. If we add a little bit more, then all will be going to the solution. Then we call it saturated solution. It means that a small amount of the solute, which is completely soluble in the solvent, which is water, to give you the clear solution like that. This means it is saturated solution. What about unsaturated solution? This is the opposite way. If you make it the opposite, like you take some of this only to the water, this is unsaturated solution because it is the opposite way. What about if it is super saturated solution? Like this, for example, you add a solute and a specific amount of solvent, but you cannot dissolve all of it even after stirring. It is still remaining some of it. This means it is super saturated solution, right? What about electrolyte? When substance dissolved in water and it conduct electricity, for example, it means it is electrolyte. Weak electrolyte, it means small electricity. What about if it is non-electrolyte? It means no electricity at all is conducted. If you look to this non-electrolyte, the lamp is not lighting at all. It means non-electrolyte. Here, small lighting, it means weak electrolyte. Here, strong electrolyte, it means strong lighting. So I think chemistry is easy. Therefore, when you have a solution like sodium chloride, for example, and you dissolve in water, you have a cation and anion. Sodium is positive, which is cation, while chlorine is negative. That's why we call it electrolyte. What about weak electrolytes? Let us take the example of acetic acid. Look here that you will see the arrow back and forth, which means there is equilibrium. So the acid dissociated into acetate and proton in aqueous. Then it forms the acetic acid again. So forward and backward, which means the ionization of acetic acid is reversible. And accordingly, it will be a weak electrolyte. So I circle here in order to show you why it is reversible reaction, and that means it occur in both directions. Therefore, it is a weak electrolyte. Then non-electrolyte doesn't conduct electricity at all. So it means that you don't have cations nor anions in the solution. Let us take sugar, like the one I used here, and you add water. It gives you aqueous sugars. From this point of view, you will see the table with strong electrolytes like HCl, nitric acid, etc. While weak electrolyte, as we said, acetic acid, hydrofluoric acid, etc. Non-electrolyte is like urea, methanol, ethanol, glucose, sucrose, these types of sugars. Then if you look to the hydration, it is a process, right, which an ion is surrounded by water, like this one. So it is ion and it's surrounded by water molecule arranged in a specific manner. And the hydration helps to stabilize ions in solution and prevents cations from combining with anions. So this means that this is the hydration. Like, for example, look here to the water. Water is HOH. So the oxygen, as you know, has 2 bonds, while hydrogen has 1 bond. So this is how it's surrounding. Then precipitate. What means precipitate? It means that if you have a reaction and precipitate occurs, this usually involves ionic compound, right? So, and this is what you have seen when you do the lab work as, you know, lead nitrate, for example, plus sodium iodide. We usually start with positive followed by negative. And again, the same here. And when we do such a reaction, then the positive will take the negative. So lead will take iodide, positive and negative. It will take lead iodide plus sodium nitrate. So this lead iodide is a precipitate, right? And it forms a yellow precipitate, as you can see here, right? Sodium nitrate is aqueous. It is solution, so you don't see it as a precipitate. So that's why I usually say lab work is really fun when you do it. And this is a molecular equation. A molecular equation, it means that to balance. So sodium iodide here is sodium nitrate. So when it is 2 sodium here, it must be 2 sodium here as well. When it is 2 nitrate here, is also 2 nitrate here. Only 1 lead here, 1 lead here, etc. So this is how you do the molecular equation. And if you do it in positive and negative, this is very important when you do chemical reaction. Make the positive and negative. This will make it easy for you. So for example, here, lead will take iodide, lead iodide. Sodium will take nitrate. And start with positive followed by negative. This is the rules of chemical equation. And that's why we call this ionic equation, which means that you put positive and negative. And this is lead iodide precipitate. So this, you could call it also net ionic equation. Sodium and nitrate, this is, as I told you, this will be in a solution. From this point of view, we will talk about solubility. Solubility, as I have shown to you, this is the maximum amount of solute which dissolved in the solvent at a specific temperature. So it gives you a clear solution. This means a solubility. And the soluble compound, I think you already know it about salt, for example, it is sodium chloride or lithium, potassium, etc. So should use a soluble compound, and this is insoluble compound like this type of chromate, for example, etc. Then we take it in the periodic table. This it showed you in the arrow here about the alkali metal and also the groups of alkali metal and alkali earth metals. Here also the halogens, it is fluor, chlor, brom, iodide, etc. So, and this is the noble gases. Then we took to another point, which is precipitate of several kind of precipitate. Look to these colors when you work in the lab. You will see different colors of precipitate. For example, here you will see that this is cadmium sulfide. For example, this is lead sulfide. This is sodium hydroxide. This is aluminum hydroxide, etc. So these are we can explain it by molecular equation, ionic equation, and non-ionic equation. So we take some examples like potassium bromide plus magnesium sulfate. If you react both together, again, positive and negative, I think you know it now, then you start to do it like this way, positive and negative, make K2SO4. Then the magnesium will take the bromide, magnesium bromide. So you see, try to practice with examples like that. You will find it is really easy to work with, and what is soluble, what is insoluble. So in the final, if it is KBr with magnesium sulfate, it is like that. Then write a balance equation reaction or ionic equation showing strong electrolytes, identify and cancel the spectator ions on both sides of ionic equation. Check what is the charges of the number of atoms in the net ionic equation. Write the net ionic equation. So if you put a reaction, then try to put such or to answer such questions. This is a very good practice. Let us take the example of silver nitrate plus sodium chloride. How you do it? Again, positive, negative, positive, negative. So silver will take the chloride to give silver chloride, while sodium will take the nitrate to give sodium nitrate, and this is solid while this is aqueous. Then you start to do the ionic equation and to do it in the balance. So like this way, then you will get the final answers. From this point of view, you also studied of acid and bases. And the most example of is famous is aspirin. When you have headache, then you take acetyl salicylic acid, which is called aspirin. This is synthetic organic chemistry. So in addition to being the basis of many medicinal and household products, acid-base chemistry is important in industrial process. As I told you, chemistry is the life. So it is what we eat, what we have the clothes, what is in industry is usually chemistry is part of it. So then we can discuss here about the properties of acids. What is the definition of acid, right? So in very simple way, acid is a compound which can donate proton. And if you have a litmus paper and you put it in acid, then it will change the color from blue to red. So acid means red color, right? So it reacts with certain metals to produce hydrogen gas like magnesium and ferric. For example, if you take HCl, why it is acid? Because it changed litmus paper from blue to red and it donates hydrogen. If you react with magnesium, you will see hydrogen gas is evolved. So it donates hydrogen, and magnesium will react with chloride to give magnesium chloride, right? And here is a reaction. So if you make the reaction, you will see that the hydrogen gas is like that. It reacted with carbonate and the bicarbonate. Then you see the bubbles. So, and this is very famous reaction. If you take any sodium carbonate or sodium hydrogen carbonate and reacted it with HCl, you will see the bubbles of carbon dioxide. This is a famous reaction when you start acid-base chemistry in the lab. And the aqueous acid solution, it conducts electricity. What about properties of base? It is the opposite way. It has a bitter taste. If you have litmus paper, then it is the opposite way. The litmus paper will be changed from red to blue. So alkali means blue color of the litmus paper. And the aqueous solution, it conducts electricity. So example of this is ammonia. And it should have 3 bonds connected with hydrogen, 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 or hydroxyl group like OH. So it is anion in this case. Why? Because, hydrogen is only 1 bond, but oxygen must be 2 bonds, right? So then in broader solution, the Danish scientist Jonas, he gave a definition that acid is proton donor. So acid, when conjugated, it gives proton. That's why they call it proton donor, right? And this, it showed you how it donate the proton. While base is the opposite way, is proton acceptor. So proton donor, acid. Proton acceptor is a base, right? So if Arrhenius theory, according to the Arrhenius theory, the acid is total ions, for example, to produce proton. That's why the acid is H3O. Why? Because HA, when reacted with water, it gives proton. So it will be H3O. Why we put here positive? Because as I told you, oxygen has 2 bonds, but now oxygen has 3 bonds because it has 3 hydrogen. So when it has extra bond, it means we have to put positive charge. So it is 3 bonds plus A. While if we go to base, like it is a substance that if it dissolved in water, it gives hydroxyl ions. So like base plus water, it gives BH plus hydroxyl group. So what is the difference here? So acid, it has H3O positive, while base is the opposite way. It reacts with water, then the base will take hydrogen, then it is OH. And why it is negative here? Because now it is the opposite way. Oxygen must have 2 bonds, but now it have only 1 bond, which is hydrogen. When it is less, you put negative charge. O has less bonds, only 1 bond, then you put negative charge. Oxygen here has 1 extra bond, then you put positive charge. Here is cation, and when this is positive, while here is negative, which it means it is anion. Then this is a limitation. There is restriction to aqueous solution. If you take this Arrhenius equation, if you take acid like HCl and react it with water, then what will happen? The water will take proton because acid is proton donor. Then it will be H3O, and as I explained you, it will be positive. This is hydronium ion plus chloride negative. So the ionization of HCl in water to form hydronium ion and the chloride, and of course chloride here is negative, right? Then the hydrated proton, which is H3O, as I told you before, this equation reaction is Bronsted acid, which is HCl, is proton donor, while base is accept the proton. Experiments also, it showed that the hydronium ion is further hydrated so that the proton may have several water molecules associated with it. Because of the acidic properties of the proton are unaffected by the degree of hydration, in this ticket we'll see that use hydrogen aqueous to represent the hydrated proton. So this is a hydronium ion, as I told you, is oxygen, but surrounding by 3 protons. It should be only 2. That's why it is positive. So this, it showed you why we put positive charge on hydronium ion. If you take an example about base plus acid, so base like NH3 plus water, then it will give you NH4, right? It will take a proton, and now nitrogen, it should be 3, but now it is 4. When it is 4, one extra, then you must put positive charge, and the opposite way. Oxygen was 2, but now it is only 1, so it will be negative charge. So the ionization of ammonia in water to form ammonium ions and the hydrated ion. So please note that water can act as an acid or base. So it is amphoteric solvent. Amphoteric because it has means that it can act as acid and it can act as a base, right? So it depends on the media, right? So household acid and the base. So this is, it showed you, as I told you, this acid base, it's used in industry. If you look to this, for example, like sodium hydroxide, if you look to juice, like citrus acid, so some is base like this with OH, some is acid like this one and this one, etc. So what we are using in cleaning sometimes is chemicals, which is like sodium hydroxide and its derivatives. What we use to drink, it contains some acids as well. That's why if you eat a lot of oranges, you will get some kind of a stomach trouble. Why? Because it contains acid, right? Or if you drink a lot of lemon or you eat 2 or 3 lemons, then you will feel it, right? Then acid base, it is an electrolyte of substances that ions in the solution. So if you take a strong electrolyte, like a strong acid or a strong base, for example, HCl, it is a strong acid, nitric acid, strong acid. That's why you have to be very careful when you work with acids, because it can really burn your hand. It is very dangerous. Also, if you work with strong bases like sodium hydroxide or potassium hydroxide. So for strong electrolytes like strong acid, for example, HCl, it will dissociate to hydrogen and chloride. Again, if it is, but it is weak electrolyte, then it is, as I explained to you before, is about reversible reaction. I think you remember it already. What is the meaning of weak electrolyte is a reversible reaction. What about another definition? And as I usually say, don't memorize things. Look to the word and start to guess what it is. For example, monoprotic and polyprotic. What is the difference? Mono, poly. Mono, it will be only 1 hydrogen. Poly, it will be 2 or more hydrogen. And the protic, which means proton. So the acid resulted in only 1 hydrogen atom is called monoprotic acid, monoprotic. While the acid has 2 or more, it will be 2. For example, HCl, only one nitric acid. This means it is a strong electrolyte, which is a strong acid, as we explained. While acetic acid, now I can hear you, it is equilibrium or reversible reaction. It means it is weak electrolyte. If you take polyprotic acid, for example, H2SO4, now two hydrogens. So it dissociated to hydrogen and sulfate, and it is a straightforward reaction, not reversible, irreversible, right? Then it is strong. But if you take HSO4, it is reversible. It means it is weak electrolyte. While triprotic acid like H3PO4, it is weak electrolyte because then it is weak acid. And again, H2PO4, it is also weak electrolyte or weak acid. HbO4 is weak electrolyte or weak acid. So this is the example about strong acids like HCl, HBr, etc., while weak acid like such examples. So please practice on this and see why it is strong, why it is weak acids. Then, what do you think if we add acid to base? Acid and we add base, then it will be neutral. So if you take acid and put litmus paper, it will change to red. If you take a base and put litmus paper, it will be changed to blue. But if you mix together and you put litmus paper, it will not be affected. Why? Because you get the salt, which is neutral. It means not positive, not negative, like in this equation. If you take HCl and sodium hydroxide, then you will get the sodium chloride as we explained before, positive, negative. And this is a ionic equation, and you can, I think, practice on that easily now. And H plus OH will equal water. So the neutralization reaction, it can also occur with weak electrolyte, right? So if you take, for example, such equation, hydrogen cyanide plus sodium hydroxide, and please remember that this is very dangerous when you work with cyanides. It is very, very toxic. So please be careful on that. So can you practice again on such equation? Yes, this is weak acid like hydrogen cyanide plus base. It will give you salt and water, right? And this is a ionic equation as usual. Then if you take another example about sulfides, carbonates, etc., it is the same way. And this we explain to you. HCl, if you add sodium carbonate, you will see bubbles immediately, especially if when it is concentrated solution. Why? Because it reacted with sodium carbonate to give sodium chloride, and then this unstable compound, which dissociated immediately to water and the carbon dioxide gas. That's why you see the bubbles due to carbon dioxide, or we call it effervescence, right? And this is the ionic equation by positive and negative. I think chemistry is fun, especially when you understand it. Don't memorize it, then it is easy for you to follow the example, and especially when you make it in the ionic form, then it is easy to understand the positive and the negative. Then we'll go to the term of oxidation reduction reaction. So the term oxidation, it means that reaction refer to half reactions that involved loss of electrons, right? So this will give you the meaning of oxidation, to donate the combination of elements with oxygen, right? And reduction reaction is a half reaction that involves the opposite way, gain of electrons. So oxidation means addition of oxygen. Removal, when you add oxygen, it means you remove electron and remove proton. While reduction is the opposite way, removal of oxygen. So addition oxygen, oxidation. Removal oxygen is reduction, which it means also addition of electron and addition of proton. Let us for everything, usually take examples. So if you take, here is magnesium and here is oxygen, it will give you magnesium oxide. So now this is the oxidation reduction reaction or electron transfer reaction. But so magnesium will give you magnesium plus electrons. This immediately, it lose electrons. When it lose electrons, it means it is oxidation, right? Then what do you expect about reduction? Gain electron, right? Lose means the compound give the metal plus electrons. So when it is plus in the product, electrons in the product, it means lose electrons. And the opposite way. Now it is gain electrons. So oxygen will gain electrons, right? It means, right, I can hear you. It is reduction reaction or reduction half reaction. So it is gain electron. It means that the electron in the reactant, it is on the left-hand side. So, and the total net equation is, as you can see here, it is oxidation, reduction, reaction, right? Then you practice it in the ionic form as well. Then this is another example about zinc. Now I can hear you. Zinc will give zinc plus electrons. So what does this means? Yes, I can hear you, oxidation. And the second one is it gain electron. It means electron on the left-hand side, which it means that it is reducing agent. So it is a reduction reaction. So this is examples which you can practice. Copper wire, for example, it reacted with silver nitrate in the same way. So in this case, copper will donate electron, right? Then it will gain electron, which it means it is reducing. And so the oxidation is half reaction and it is loss of electrons, while reduction is the opposite way. And from this point of view, it is the oxidizing agent, which means a species that oxidizes another species. So itself, it reduced, right? So oxidizing agent and reducing agent. Oxidizing agent, what it means, it is species that oxidized another species. So itself, it is reduction. What about reducing agent? It is reduces another species. So itself, it is oxidized. So please, this is a tricky point. The oxidizing itself, it is reduced, while the opposite way, reducing itself, it is oxidized, right? So this is a definition. Now you can see about the charges of the molecule, and you can practice about it. What about hydrogen plus chlorine, for example? And what is positive and negative? So try to practice with such examples, and we will solve problems together in the next video. So I give you a chance to do some equations by yourself. So then it comes to, if you use the rules to assign oxidizing number. So the free elements, for example, have oxidation number of 0, like these examples, while here non-metallic ions, the oxidation number is equal to the charge, like for example, lithium, iron is 3, oxygen is 2. And when the oxidation number is -2, like hydrogen peroxide, for example, then if you take another examples of the hydrogen is equal 1, while in the binary compound like CaH2, in this case, it is -1, right? So there is group 1A of metals, which is +1, and group 2A metals is +2, like in fluorine, for example. And the sum of the oxidation number in a molecule is equal to the charge of the molecule of the ion, right? So the oxidation number don't have to be integers. It can be, it doesn't have to be, right? So the oxidation number of oxygen, for example, in superoxide ion is -1. What are the oxidation number of all the element in HCO3, for example? Can you calculate it? Yes, HCO3, which is -1, right? So the oxygen is -2, hydrogen is +1, right? So it means that 3, which is the oxygen here, is 3, right? Multiplied by oxygen, which is -2, plus 1, which is the hydrogen, plus question mark. This will equal -1. So now you can see that the carbon is 4. And this is what we usually say, that hydrogen should be 1, oxygen is 2, nitrogen is 3, carbon is 4. And this is how you can calculate it. And this is a periodic table. So what are the oxidation numbers of some of the compounds like here? Please try to practice with such examples like in the same way. And also my advice that for the student is also good idea that you work sometimes in group. This is good for you, so you can share the knowledges, and practicing is really important in the chemistry. If you take, for example, potassium permanganate, KMnO4, this is a purple color, right? And this also is a green color compound obtained when oxidation number of the manganate. So you can calculate the oxidation number in this way, K and Mn and O4. So the potassium and the manganese and then O4, right? Now you can practice in the same way. 1 + 1, which is the oxidation number of manganese, and oxygen, as we told you before, it is -2. So 4 multiplied by -2, then it will equal 0. So -7, and then, so the oxidation number of manganese at the end, it will be 7. So I think it is easy to calculate now the oxidation number. And if you take K2MnO4, it is in the same way, 2, and it is 1. And manganese, right? Then oxygen 4 multiplied by -2 will equal 0. Then you continue to calculate it. Then you will get the oxidation number of manganese. In this case is +6. So a KMnO4, then the manganese could be +6 or could be +7. And then types of oxidation reduction reaction. It is a combination reaction. Combination. And as I told you, look to the name, combination. Two things I combine together, A and B will equal C. Like, for example, if you take aluminium and bromine, and be careful, of course, because bromine is really not very healthy. So if you make such reaction, please do it in the fuming hood. So aluminium plus bromine, it will give you aluminium bromide. Then another reaction like oxidation reduction reactions. This is a very good examples here. It is reaction of single compound reacts to give 2 or more substances. What about decomposition reaction, for example? It is the opposite way. We take combination reaction, 2 things together, A, B, Q, C. What about decomposition reaction? What do you expect? It is the opposite way. C is a compound which is dissociated into A and B. Look to this example or this example for any of them. What you will see here, that this is a compound and it will give you like potassium chlorate, for example. It will give you potassium chloride plus oxygen, right? And here, if you look to this example about HGO, right? It will give you this as well. So this is a mercuric oxide. It will give mercury plus oxygen. Potassium chlorate, it will give you potassium chloride and oxygen. So this is decomposition reaction. Only one compound, give two. One compound, give two, right? So chemistry is easy, I think. What about composition reactions? It is a reaction in which a substance reacted with oxygen. Like, for example, A plus oxygen will give you B. For example, take this one, sulfur plus oxygen, it will give you sulfur dioxide. So this is an example, and this is the, when you put the oxidation numbers, then you will see it like that. Or if you take magnesium plus oxygen, right? So in this reaction, substance reacted with oxygen, right? In order to release heat or to produce a flame, right? So this is an example, right, of such reaction. What about another example here of, for example, if you take ferrous and reacted it with oxygen, it will give ferric oxide. So this is another example with reaction of oxygen. What about displacement reaction? So now we take, just look to the name, displacement, before you see the example. Displacement reaction, right? What it means, you will do, right? I can hear you. Look to this example. One element will be replace another one, right? Like, for example, A plus BC. So it will give AC and B. So it means that B will be the replacement one. Like, for example, here is this hydrogen displacement of SR, right? Then it is displacement reaction, right? Or titanium tetrachloride plus magnesium. Now, titanium will be a replacement of this metal, displacement of titanium instead of magnesium, right? Chlorine plus potassium bromide is the same way. It will give you a halogen, which is bromine, because bromine now is displacement reaction of chlorine. So try to take the examples, then you can explain the text. Don't memorize the text at all, right? Then, and this, if you put the oxidation state, of course, you can practice on that. So displacement reaction, again, zinc plus HCl, it will give you, the hydrogen will be displacement of the zinc, as you can see. So the same element is simultaneously oxidized and reduced, like in this case, chlorine and hydroxyl, it will give you, this will be oxidized, while this will be reduced. So it has the oxygen, it is oxidized. When it here it lose, then it is reduced. So lose electrons and gain electrons, as we have said before. So it can act simultaneously, oxidized and reduced. Then we go to another equation about the concentration of the solution, right? So it is the amount, as I explained to you before. This is a really concentrated solution, as I have told you. So, and this will equal N divided by V, and N is the electrons, that's the number of moles of the solvent, of solute, sorry. V is the volume of the solution in liter, right? So this is the equation, and the molarity is the amount of solute in moles of substances. So the molarity will equal the moles of solute divided by liter of the solution. So the molarity is the amount of substance in moles divided by mass in kg, right? So, and you can have the equation of the weight, which is molarity multiplied by volume by molecular weight. And we explained before how to calculate the molecular weight of the compound divided by 1000. So this will give you the weight. So what mass, for example, of potassium iodide is required to make 500 milli, right? We can do it together. So the weight will be equal 2.8, right, which is the molarity, multiplied by the volume, which is 500 milli, multiplied by the molecular weight of potassium iodide, potassium plus iodide will give 166, and divided by 1 liter. This will give you the weight, right, which is 232 G potassium iodide. So this is very simple equation to calculate for you the weight with the meaning of molarity and in a specific volume, right? Another example, if you would like to calculate the 1.52 of potassium dichromate, then you must calculate the molecular weight of potassium dichromate. How much? Potassium plus chlorine plus oxygen. Remember, of course, that the oxygen, for example, is 7. So you multiply 7 of 16, right? So each, how many atom? And you multiply by the atomic number into 50 milli volumetric flask. So you add water to bring up to the solution. So it is the same again, molarity, right? So the molarity is equal the molarity, weight, divided by volume, multiplied by the molecular weight. Or in the other way, molarity, volume, molecular weight per 1000, right? In any way, you can put it to calculate the weight. And if you calculate the molecular weight, of course, you will see that it is 294. This will give you the molarity, right? So you can work more with such examples. How to prepare solution? You usually add the weight amount of solute. As we explained, the solute is a solid in a volumetric flask. So you put the solid first, right? This to be very accurate. Put the solid first in the volumetric flask, like this one. Then you start to add the solution to the flask. Then you will get a clear solution. Here you can see some examples. Another example, you put here the amount of solute, and then you start to add the solvent here until exactly this. So you get accurate solution in this way, right? So I think this is how you calculate it in this way, right? And the dilution solution, so the dilution is as I explained to you before, dilution is the opposite of concentration. When it is diluted solution, this means that it is made to make the solution more and more diluted, right? This will give you dilution solution, right? So this is an example of moles of solute MV1 equal MV2. And this is just a photo how to dilute solution. You can even make such experiments at home. Now you can have such example, MV1 equal M1V1. Then you can calculate such examples, and we will work together in the next video about how you can solve such problems and practice on it, right? So I would like to sincerely thank you for your listening, and please don't forget to give us the constructive criticism. Thank you very much. يا رب يكون علما ينتفع به, and please try to spread with your colleagues. Hope it is benefit for all of you. Thank you.